Good afternoon. We will just get started on what we were doing in the last lesson. So yesterday we were talking about the geometric series. We say that with a geometric series, instead of a common difference, what you have is a common ratio. And you can work out what the common ratio is in this way. So you have your geometric sequence, you have A, U2, U3, and so on. So your common ratio, R over A. This is equal to U3 over U2, and this is true, so on. Okay, so the difference, the ratio between any two consecutive terms is
ndamete kuja chitopata wekoshonga pwandu mangome aye kulimo mangome aye mange uli netutu mo.
okay, that's better. Right, so we look at question number 6 now. With number 6, what we are told is that the third term, U3, this is equal to 6, and the fourth term, U4, this is equal to 27. Now we have to work out the value of A as well as the value of R. Now this one is very simple because we're given two consecutive terms. Now when you're given two consecutive terms, you just divide the one that comes later by the one that comes before, and then that is your R. So here we know that R is equal to U4 divided by U3. So this is 27 divided by 6. So you rewrite this in its simplest form. Here, 27 divided by 6. This is 9 over 2. So your R is 9 over 2. Now we just need to work out the value of A. So to get the value of A, what we can do is use these terms that we have. We know that U3 is equal to A multiplied by R, which is 9 over 2 to the power of 3 minus 1. And this should be equal to 6. Okay, so that's what we have. Then we simplify this and make A the subject of the formula. So we'll have A 9 over 2 to the power of 2. This is equal to 6. This means that A is equal to 6 times 2 over 9 to the power of 2. So this, you can just work it out on your calculator. This is 24 over 81. And this gives you 8 over 27. Okay, so now you know what your A is. A is 8 over 27, and R, when we worked it out, R is 9 over 2. So that one is not too difficult, pretty simple to do. And with number 7, we are given a sequence 8, 6, 12. Then we say the sequence goes on, and then we stop at 3072. Now we're asked how many terms do I have in the sequence that stops at 3072. So to work this out, I need to know what my A is. That is simple because I can just see it. There it is. So I say my A is equal to 3. I also need R. R is the ratio between term number 2 and term number 1. So I say 6 divided by 3. This is equal to 2. Okay, so now I know what A is, I know what R is. I just need to work out the value of n. So I'm looking for the value of n such that this nth term is equal to 3072, which is the term at which I stop over there. So the formula for un, this is just a to the power of, a times r to the power of n minus 1. But I know what a is, I know what r is, I can just work this out. So a over here is 3, so I have 3 multiplied by 2 to the power of n minus 1. This is equal to 3072. I want to make n the subject of the formula, so I need to divide by 3 on both sides. I get 2 to the power of n minus 1. This is equal to 1024. Then 1024, I can rewrite it as 2 to the power of 10. This means that 2 of n minus 1, this is equal to 2 to the power of 10. Now my bases here are the same, so it means that my exponents should also be the same. So I have n minus 1, this is equal to 10. This means that 10 is equal to 11. Now if 10 is equal, n is equal to 11, this means that there are 11 terms in the sequence. Okay, great. And number 8, we are given the second term, this is 4. And then we are given the sixth term, which is 1 over 4. And what we need to work out is the first term and the common ratio, and then list the terms. Okay, so when we're given the second term and the sixth term, we can always work out R and A. So we know that the second term, U2, this is just A multiplied by R to the power of 2 minus 1, and this should be equal to 4. So this is the same as AR to the power of 1, because 2 minus 1 is equal to 1. This is equal to 4. So this is your first equation. Then we do the same thing with the second one. We have U6. This is equal to A r to the power of 6 minus 1, and this is equal to 1 over 4. So with this one, I have A r to the power of 5. This is equal to 1 over 4. So this is my second equation. So what I do with these equations is I'm going to divide them, and then I solve for r. Or what you can do is make A the subject of the formula in both of them, and then equate the two. That is also fine. So doing that, I have A r to the power of 5. This is equal to 1 over 4. Then I divide this side by A of r, and I divide this side by 4. So what I have here is the A's will cancel, and I'm left with r to the power of 5 minus 1. Remember your laws of exponents. If you're dividing, the bases are the same, then what you should do is subtract the indices. So this is 4, and then I have 1 over 4 divided by 4. This is just 1 over 16. Okay, then r to the power of 4 is equal to 1 over 16. This means that r is just the fourth root of 1 over 16, and this is equal to a half. So I have my r, which is equal to a half. Now I use the first equation that I got over here, this first one, substitute r in there, and then work out a. You can also use the second equation. You'll still get the same answers. It doesn't matter. So I have a multiplied by r, which is a half. this is equal to 4. Okay, so divide by half on both sides or multiply by 2 on both sides, you get A is equal to 8. So now I know what my A is and I know what my R is. I think, sorry, over here, R can also be equal to negative a half. So there are two possible values. I forgot that. Okay, so when you take the fourth root, R can be positive or negative. So it's not just one value for R. Then you can write down the sequence. When R is equal to a half, what you have is the first term is 8. Then to get the next one, you multiply 8 by half, you get 4. Then you multiply 4 by half, you get 2. Then you multiply 2 by half, you get 1. 1 by half, you get half. Half by half, it's a quarter. And it continues, the dots there. So it continues in that way. Then the sequence, if R is equal to minus half, is similar. So the first term remains the first term, it's just 8. Then I get minus 4, 2, minus 1, half, minus 1 over 4. Okay, so that is how the sequence will look like. Let me just read the question out and see what it is saying. Okay, sorry, my A is not right. So if R is equal to negative half, it means my A is negative 8. So I have negative 8, positive 4, negative 2, positive 1, negative a half, and then it continues in that manner. So when R is equal to negative half, then this means that A is equal to negative 8. Okay, so that's how we would work that one out. Then number 9. Number 9, we are told that the first three terms of GP are this 59,049. Then comes 19,683, and then we get 6,561. Okay, so these are the first three terms of our GP. Now we are told that the nth term, this is less than 0.01. Now we want to calculate the least value of n. So we're trying to find the nth term, or the first nth term, that is less than 0.01. So here we write down the formula for un. So we're trying to find when is un less than 0.01. Now we know that after this first un, all of them after that will be less than 0.01. Okay, so we want to find the very first one that is less than 0.1. So we write down our formula. This is a r to the power of n minus 1. This must be less than 0.01. Now we know what our a is. This is 59,049. R, we work it out by dividing 19,000 over 59,000. We get 1 over 3. So this is 1 over 3. Then I have n minus 1 should be less than 0.01. So this is a simple inequality that you should know how to solve. Now to solve this, we divide by 59,049 on both sides. So I have 1 over 3 to the power of n minus 1. This is less than 1 over 590. Okay, this looks like 5 million. Let me see, 504,900. Okay, so this is 5,904,900. Okay, then what you do again to solve this one here, you can take logs on both sides because you are interested in n minus 1. So we have n minus 1. This is less than log 4. Okay, then you divide this by log of 1 over 3. So when you work this out, you get n minus 1. This is less than 14.191. This means that n is less than 15.2. You can round it off to that. So this means that any term whose number is less than 15.2 will be greater than, maybe I'm not saying that correctly, but the term 15, you will see that it is greater than 0.01, and then after that, then it will be less than 0.01 because our terms are getting bigger here. So the nth term that we are looking for, this is term number 16. Okay, so that's how we would do that one. Okay, so we're about to move on to the sums of geometric progressions. Before we leave this part, do we have any questions on what we have done so far?
Yes, ma'am.
Yeah.
Ma'am, can you please go back to the step there that by 1 over 3 to the power of n minus 1 is smaller than 1 over 5 million,
Mm-hmm.
9 over 900.
Yes.
Can you please explain how you got to the following step, the step after that?
I took log on both sides. Is that what you mean? From here
Yes, ma'am.
to go there?
Can I just quickly write it down, please?
Yeah. So I just took log on both sides. Then n minus 1 is an exponent, so it will come down. And then I
Yes,
can
ma'am.
divide by log of 1 over 3. I see what I did wrong. Log of 1 over 3 is negative, so my sign should change direction. Okay, so here. Sorry. Okay, so I take log on both sides, but log of 1 over 3 is negative, so my sign should change direction.
Mhm. Oh, so ma'am, after to
Mm-hmm.
get n minus 1 on its own, you divide by
Yes,
log 1
the
over
log,
3 side.
yes,
Oh, okay, I see. And then you work it out using the calculator,
yes,
and you take the negative 1 to the other side,
yes,
which how you got 15.2.
yeah,
Okay. Well, thank you, ma'am. I get it.
okay. Do we have any other questions? Are we fine with working out um, A or R or the nth term with geometric progressions before we move on to working out the sums of geometric progressions? Okay, I hope your silence means that you are fine and we can move on. So the next thing we look at is the sum of a GP. Okay, so we know that a GP is in this form. We have AR1, AR2, AR3, and it continues in that way. So a geometric series, remember a series is just a sequence, it's not a sequence, it's just you take a sequence and then you add all the terms together. So instead of having a comma between the terms, you just have a plus. So this is a series. And then we have dot, dot, dot like that. So you keep adding all the terms in the sequence, and that gives you all the terms in the sequence, and that gives you a series. Now we write it using sigma notation. So we write it sometimes like this. So this sign here, sigma, is a Greek letter. It is used to represent the sum. And then here we have an index. We say k is equal to 0, and we end at n. And then here we have a r to the power of k. This is just a shorter way of writing what I have over here. So what you do is this k, you will start by making it 0, then you add it to when you make k1, then you add it to when you make k2. So if I give you this, to rewrite it the longer way, you would just say a r to the power of 0. So I start, this is my starting point, and then this is my end point. So how you would do this, the first one, you start k is 0. Then the next step, you substitute k is 1. So you have a r1. Then the next one, k is 2, a r2. Then after that, k is 3. And then you keep going until you get to your n over there. So you'll only stop when you get to a r to the power of n. So we can look at one example. Let's say I give you the sum k is equal to 0 up to 3 of 2 times half to the power of k. So this is a geometric series, and we will talk about the sigma notation so far. I just want to, a little bit later, I just want to illustrate how this would work. So remember, we are counting our k's. So k starts at 0. This tells us our starting point. And then this one here tells us our ending point for k. So we'll substitute with the first one until we get to our end point. So this, the sigma, remember, just means sum. Add up all those terms. So the first one will be 2 times half to the power of 0. Then 2 times half to the power of 1 plus 2 times half to the power of 2 plus 2 times half to the power of 3. And 3 is my end point because that is what it says over there. So this is how we shorten all of this and compress it into that. Okay, so we'll, after we're done with the sum of a geometric sequence, we will talk about the sigma notation. So this is just an illustration of what we mean. So this is the long way of writing it, and this is the shorter way of writing it, but they are doing exactly the same thing. So with the sum of a geometric sequence, we say Sn, this is equal to a r to the power of n minus 1 over r minus 1, or you can use this formula Sn, this is a 1 minus r to the power of n over 1 minus r. Whichever formula you use, your answer will be exactly the same. I see sometimes they say use this one when r is greater than 1 and use this one when r is less than 1, but it does not make a difference which one you use. Either way, your answer will be exactly the same. So we know what A is. A is the first term. We know what R is, that is the common ratio, and then we just substitute to get the formula, to get the answer, sorry. Then we can work out an example. First one, we're given this series, 2 plus 6 plus 18 plus 54, and then it continues until you have 8 terms. Now the question is, what is this S8 equal to? So we want to find out what the sum of the first 8 terms in this geometric progression is. Now to do that, we know what A is. There it is. To work out what R is, we just look at the second term and then we divide it by the first one. So R is equal to 6 divided by 2, and this is equal to 3. So now that I have my A and my R, let me just write that A is equal to 2. So I have my A and I have my R. To work out S8, I will use both formulas to check, do I really get the same answer? And I should. So the formula says it's A multiplied by the first one, which is the one that says when R is greater than 1. So I say 3 to the power of n is 8 minus 1. And then I divide this by R to the power of n minus 1. Sorry, no, R minus 1. Okay, that is the formula. Then this, you just work it out on your calculator. If you do it correctly, you will see that this is 6,560. Then you can also try using the same formula which says it's for when R is less than 1. See if it works or not. So you write it like this. This is 2. I have 1 minus 3 to the power of 8 over 1 minus 3, and you'll notice that the answer is still the same. So it doesn't matter which of the formulas you use. You're not really restricted that you must use the first one when R is greater than 1, or you must use the second one when R is less than 1. It doesn't actually matter, because in either case your answers will be exactly the same. And I personally prefer to use this one over here. Okay, so you can use the other one when R is greater than 1 or it's less than 1. It's up to you. So pick one. And I think it's easier if you just have to remember one formula than several. Okay, then we look at another example of a series of 8 minus 4 plus 2 minus 1 plus half. And this continues the dot dot dot, but in this case I have 10 terms. Now when I have 10 terms here, I need to work out what my A is, what my R is. Now what you see with this sequence, with this series, is that the terms are alternating, goes positive, negative, but it still is a series. So you should look at it as 8 plus negative 4 plus positive 2 plus negative 1 plus half, and then plus, and then it continues in that manner. So a series deals with a sum. So you are adding numbers. It's just that some of them are positive, and when we have two signs here next to each other, positive and negative, you get negative. Okay, so don't let that throw you off. So A is easy to see because it's the very first term. So A is 8. And then to get R, I take my second term, which is that one, negative 4. And then I divide it by my first term, which is 8. So I have negative a half. So now that I know what A is and what R is, to work out the sum of the first 10 terms is easy. So I say S10, this is equal to A, which is 8. Then I prefer this one, 1 minus negative a half to the power of 10. Then you divide this by 1 minus negative a half. So you can also try it with the other formula. You will notice that the answers are exactly the same. So doing this, you just work it out on your calculator, and what you should get is 341 over 64, and this is approximately 5.328 if I want to write it to 3 decimal places. Okay, so again, if you want to work out the sum, all you need is A and R, and then pick whichever of the two formulas you want to use. So you can also try it to use the other formula that says it's for R, which is greater than 1. You will see that your answer is exactly the same. Now let's look at some of the questions in exercise 5.3.2. So start with number 1A. You are given the series 4 plus 20 plus 100 plus 500. Then it continues. Now with this one, we are asked to work out what R is, and then work out the next two terms. So R is easy to do. You take any two consecutive terms and then say the one that comes later divided by the one that comes before it. So I can say 100 divided by 20. So 100, this is R, is equal to 100 divided by 20. This is equal to 5. So it doesn't matter which two terms you pick, as long as they are two consecutive terms, and it is the one that comes later divided by the one that comes right before it. So even if I had said 500 divided by 100, you will see that the answer is still 5 for R. Then A is obviously 4, which I'm not asked to do, but it's good to take note of. Then I am asked to work out the next two terms. So here I have 4 terms, so I need to work out U5 and U6. These are the two terms that I need to work out. Now I know that U5, this is given by A, which is 4, R, which is 5, then I have 5 minus 1. So this is just 4 times 5 to the power of 4, and this you work it out on your calculator. I have 2,500. Or you don't even need to use this formula, because you know what the fourth term is. To get the next one, you just multiply it by R. Okay, so either way, you should get the same answer. And then U6, here I got 12,500. So I multiply the previous one by 5, or again substitute into the formula, and your answers should be the same. So when you work out U6, did you also get 12,500? Please let me know.
This one is 4.5.
Okay. Right, then let's look at B. We have 45 plus 15 plus 5, and then it continues in that manner. We have to work out R. R is just 15 divided by 45. Remember, it's the one that comes later divided by the one that comes before it, not the bigger one divided by the smaller one. So this is equal to 1 over 3. And then we have to work out the next two terms. So if I have the third term, u4, this is just 5 times r, which is 5 times 1 over 3. This is 5 over 3. And then u5 is just the same as u4 times 1 over 3. So it's 5 over 3 times 1 over 3. This is equal to 5 over 9. Question 2. Yes.
I'm not sure if it's just my screen, but you stop sharing.
Is it? Let me see. Okay.
Yes,
Let me know if. Okay, you can see it now. All right.
Yes.
Okay, then that's how we would get U4 and U5. I just take this term over here, the third one, then multiply it by the common ratio. That will give me the fourth term. And then the fourth term multiplied by the common ratio will give me the fifth term. Then number 2, I am asked to find the sum of the first 12 terms in the sum of the first 12 terms, and my series is 0 0.1, 0 0.3, 0, sorry, it's a series, 0 0.9, 2.7, and so on. So that is my series. There are 4 terms in the series listed, but I need to find the sum of the first 12. So to do that, I can work out what R is. R is just 0 0.3 divided by 0 0.1, and this gives me 3. A is the first term, which is clear to see. So I have A is equal to 0 0.1. Now to work out the sum of the first 12 terms, this is just equal to A, which is 0 0.1, multiplied by 1 minus R, which is 3 to the power of n, which is 12. And then I have 1 minus 3. So again, you can use the other formula, but you will notice that the answers are exactly the same. Now this one, you just type in on your calculator and see what you get. So we have 0.1, okay, I am getting 26,572. Okay, is anybody else getting that?
That's correct.
Okay. Then number 3, we are told that the sum of the first 5 terms is, okay, let me read the question here. Number 3, we are told that the sum of the first 5 terms is 18, and the sum of the first 6 terms is negative 9. Oh no, sorry, I'm reading it wrong. We have to find S5 and S6 when the geometric progression is this 18, -9, and 4.5. So, okay. So then it says after we have found S5 and S6, we need to work out what the sixth term is equal to. Okay, so to do this, we know what A is. You can just see it. Then write that down. A is equal to 18, and R, this is equal to -9 divided by 18. This is equal to -1/2. Okay, so now that we know what R is, working out S5 and S6 isn't difficult. So we know that S5, this is A, which is 18, then 1 minus R, which is -1/2, to the power of 5. Then I divide this by 1 minus -1/2. So again, this you do on your calculator. I got 12.375. Did anybody else get that?
Yes. 12.375.
Okay. And then the sum of the, we said S6, and this is equal to 18, 1 minus -1/2, the power of 6. Then I divide this by 1 minus -1/2. So again, this you do on your calculator. I got 11.8125. Okay, so it seems a little strange that the sum of the first 5 terms is greater than the sum of the first 6 terms, but that is because some of the terms are negative. So when you add the next term, it subtracts from the total sum. So that's why your sum is less than the one with less terms. Now we are also told to work out the sixth term. Now if I have my terms here, I have A, U1, sorry, no, U2, U3, U4, U5, and U6. Now when I add these together, this gives me S5. And when I add all of them together that I've written here, I get S6. So if I want to work out U6, I can just say this is the sum of the first 6 terms minus the sum of the first 5 terms. So I do that, or I can use the formula. In either case, I should get exactly the same answer. So when I do that, what I get is -9/16. So when you work this out using this formula, be careful that you don't use the rounded off answers. If you use the rounded off answers, you will see it is not exactly that one. Okay, or check when you use the formula and say U6, this is equal to A, R to the power of 6 minus 1. This is 18. My R is -1/2 to the power of 5. You will see that this is still 9/16. So doing it in either of those two ways gives you exactly the same answer. And number 4, we have to find the sum of the first 10 terms if we're given the 6th term and the 7th term. Now, when you're given two consecutive terms, it's always very easy because you just divide the seventh one by the sixth one, and then that is your R. So number 4, we are asked to find the sum of the first 10 terms, and we are told that the sixth term is equal to 32 over 33, and the seventh term, this is 1 and 31 over 33. So to work out R, we just say R is equal to the seventh term divided by the sixth term. This is 1 and 31 over 33 divided by 32 over 33. Again, this you can just work out on your calculator, and you should get R is equal to 2. Okay, now that we know what R is, we can work out what A is. So we use the sixth term. We know that U6, this is A R to the power of 6 minus 1, and this should be equal to 32 over 33. So A and my R over here, this is 2 to the power of 5. This is equal to 32 over 33. So this is A times 32 is equal to 32 over 33. This means that A is equal to 1 over 33. So I have my A and I have my R. The only thing left is to work out the sum of the first 10 terms. So S10, this is A, which is 1 over 33. Then I multiply this by 1 minus R to the power of 10. So this is 2 to the power of 10. Then I divide this by 1 minus 2. So this should be equal to, on your calculator, I got 31. So you can always check, see if my answer is correct. You type that in on your calculator with the brackets the way I've written them, and then you should get the same answer. Okay, that was number 4. Now number 5. We are given a sequence, negative 2, a half, negative 1 over 8, and then it continues until we get to negative 1 over 32,768. Now we have to work out the sum of these terms. Now firstly, we don't know how many terms they are, so we'll need to work out how many terms they are. We know what A is because we can see it. It's the first one there. We work out R, we work out N, and then working out the sum of those N terms, we'll just substitute those values into the equation. So here I can just state that A is equal to negative 2. Then R, this is equal to a half divided by negative 2. So take the ratio of any two consecutive terms where the one on the right divides the one on the left. So the one on the right is divided by the one on the left. Okay, so this is equal to negative 1 over 4. Then I need to work out how many terms I have in this sequence. So to do that, I will write down the formula for UN. This is A, which is negative 2, multiplied by R, which is negative 1 over 4, to the power of n minus 1. And this should be equal to the term that I stopped at, which is negative 1 over 32,768. Then I want to solve for n, so I divide by negative 2 on both sides. So I have negative 1 over 4 n minus 1. And this is equal to positive 1 over 65,536. Okay, so you divide by negative 2 on both sides because the right hand side is negative. Negative divided by negative will give me a positive. Then I can rewrite this side. It's 1 over 4 to the power of negative, to the power of 1 minus n minus 1. And this is also negative 1 over 4 to the power of 8. Okay, because 4 to the power of 8 is that 65,536. This negative here will disappear because I have an exponent that is an even number. So when your exponent is even and you are raising that negative number to that even exponent, your answer will be positive. So here again, my bases are the same. This is negative 1/4, that is negative 1/4. It means that my exponents must also be equal. So I have n minus 1 is equal to 8. This means that n is equal to 9. So I have 9 terms. Okay, so given these 9 terms, what I can do is now work out the sum of the first 9 terms. So I'm looking for S9, and this is equal to negative 2, which is my A. I multiply this by 1 minus my R, which is negative 1 over 4 to the power of n. Then I divide this by 1 minus negative 1 over 4. So again, this you do on your calculator. See, I'm getting negative 1.5999. So this, if I write it to 3 decimal places, I'll just get 1.600. So this is to 3 decimal places. Okay, so that is how you would do number 4. Well, that was number 5. Okay, I don't want to do too much today because this will not be in the test. I believe the test is going to stop at inequalities. So I think we can just stop here for today. Number 6 and 7, you can try them either later today or after you've written the test. So tomorrow our class was supposed to be at 11:30. I think we can still have the first hour of the class just to go over the mock test. By then, most people should have done it. No, the test is starting at 12 now. Our class was supposed to start 10:30. I think we can have the 10:30 class just to go over some of the questions in the mock test. By then, everybody I think should have done it. Then rest for 30 minutes, then you write the test from 12 to 2 o'clock. So class tomorrow, say 10:30. This will only be for 1 hour to go over the mock test. Okay, then the test is at 12 noon. Okay, so do we have any questions before we go? Is that fine? Okay, if there are no questions, then tomorrow 10:30 we'll go over the mock test. So have a good day and good luck for the test.
Okay, ma'am.